Visit acephysics.org you're looking for. It says given vectors a equals 2i hat plus 3j hat and b equals 5i hat minus 6j hat, part 1. It's a 5-part problem. Find a plus b graphically. So the first thing that I did was I wrote down vectors a and b, and I wrote them down to scale using the dots on this page. Then you want to find a plus b graphically. So you first write down vector a, then you take vector b and you put the tail of vector b to the tip of vector a, and the resultant vector is this black arrow here, a plus b. That is the vector a plus b, adding them up graphically. Part 2, find a plus b in component form. A is 2i hat plus 3j hat, b is 5i hat minus 6j hat. To add up vectors in component form, you add the x component to the x component and the y component to the y component. So this gives 2 plus 5i hat plus 3 minus 6j hat, and the vector a plus b is 7i hat minus 3j hat. This is the vector a plus b. It moves 7 in the x direction and then down 3. It's the same vector, a plus b. This is a plus b graphically. It's the same vector. Part 3. Now we know a plus b in component form. Part 3 says find the magnitude and direction of a plus b. So we want to switch from component form to magnitude direction form. A plus b equals, the magnitude of a plus b is the square root of its component squared. It's the square root of 7 squared plus negative 3 squared. The negative sign is always going to cancel out when you're finding the magnitude because the negative number squared is positive. And the magnitude of this vector is 7.6. So this vector is 7.6 units long. The angle tangent of theta is opposite over adjacent. Here's theta. Tangent of theta is opposite divided by adjacent, which is negative 3 over 7. I always take the absolute value of this number and then just put in the bearing at the end. So theta equals the inverse tangent of negative 3 over 7, which is in fact negative 23.2 degrees. I took the absolute value. I took positive 23.2 degrees, and then you just look to find the bearing. So you would start out east, and then you move south of east. So the magnitude is 7.6, and the angle is 23.2 degrees south of east. And then part 4 to this problem is repeat items 1 through 3, but now for vector a minus b rather than a plus b. A is still the same vector. It's 2i hat plus 3j hat. B is 5i hat minus 6j hat. And we're interested in negative b. So negative b is negative 5i hat plus 6j hat because you put a negative, you multiply the whole vector by negative 1, which introduces a negative sign in front of all of the components. A minus b, in fact, here what I did, I first wrote down vector b, and then I added it to a. So this is negative b plus a, which is the same thing as a minus b. It's the associative property of addition. First wrote down the vector negative b, and then I took the vector a and I put the tail of vector a to the tip of vector b, and the resultant vector a minus b is right here. Then the question is find a minus b in component form. So you take the x component of a and the x and minus the x component of b plus the y component of a minus the y component of b. A minus b in component form is minus 3i hat plus 9j hat. The magnitude of a minus b is the square root of the component squared. That's 9.48. And then finally, we want to find the direction. So here's the vector a minus b. It moves up 9 in the y direction, and it moves over negative 3 in the x direction. This is some angle theta. Tangent of theta is negative 3 over 9. That works out to be negative 18.4 degrees. So that's 18.4 degrees west of north. You start out north, and then you move to the west. So so vector a minus b in angle magnitude form is its magnitude is 9.48, and it has an angle of 18.4 degrees west of north.